I want to start today by asking you to visualize something. Something so mundane you probably haven't, looked at it closely in years. Picture your house. Specifically, I want you to look up at the roof. Now, zoom in on the chimney. What do you actually see?
Well, if you ask most people that question, they'll tell you they see a stack of red bricks,
Right, a stack of
maybe
mass.
some mortar joints. It looks solid,
Yeah,
a permanent stone column. It feels like the most durable part of the entire house.
exactly. It looks like it could survive a siege. But we have a stack of research in front of us today that suggests that image is, well, it's a total illusion.
Mm-hmm.
According to the data we're diving into, that chimney isn't a stone column at all.
Mm-hmm.
In terms of physics, it's effectively a giant vertical sponge sitting on top of your roof.
It's a vivid image, but it is chemically accurate. And that contrast between the fortress we think we have and the sponge we actually have that leads us right into the heart of this deep dive.
Yeah.
We're unpacking what the source is called the physics of decay.
And the stakes here are surprisingly high. I think most homeowners assume chimney maintenance is, I don't know, just about sweeping soot.
Right. So Santa doesn't get his suit duty.
Exactly. Or maybe fixing a loose brick here and there.
If only it were that simple.
But the sources are talking about legitimate structural failure. I mean, we're seeing repair estimates for full rebuilds that range from $10,000 up to $30,000.
Wow.
That is a staggering amount of money for something you rarely look at twice.
It is. And the root cause is a fundamental misunderstanding of the materials. We have this bias where we think, because brick is hard, it's heavy, it must be waterproof.
Sure.
But the reality is that brick and mortar are porous materials. Without the right protection, they are essentially dissolving, slowly, quietly, one rainstorm at a time.
So our mission today is to really understand that dissolution process. We're going to look at exactly how water and ice destroy masonry.
And why the stuff you buy at the big box store to fix it might actually be making things worse.
Destroying your house faster.
Right.
And how to read your chimney for signs of trouble before it falls over.
It really just comes down to understanding the enemy. And in this case, the enemy is simple physics.
Let's start with that sponge analogy, because honestly, if I walk outside right now and spray a garden hose at a brick wall, the water just looks like it bounces off.
It does.
It doesn't look like it's soaking it up like a kitchen sponge.
On the surface, sure. If you just glance at it, the water sheets off. But you have to look closer at the microscopic level. Masonry brick, stone, mortar, it's filled with thousands of tiny pores. It's a whole network of empty space.
Okay.
The mechanism at play here, and this is a key concept for everything we're going to talk about, is capillary action.
Capillary action. That's a term I haven't heard since high school biology.
It's the exact same principle. Think about dipping the corner of a paper towel into a spill on the counter.
Right. It just sucks it right up.
You don't have to push the towel into the water. The water defies gravity and climbs up the towel on its own. The brick does the same thing.
So the brick is actively pulling the water in.
It acts like a wick. It isn't just getting wet on the outside. Through capillary suction, it is actively pulling that moisture deep into the center of the brick and deep into the mortar joints.
So the water is inside the wall.
Deep inside.
Okay, but playing devil's advocate here, does that really matter? I mean, rocks get wet in nature all the time. Cliffs get rained on. Why does it matter if the inside of my chimney is damp?
In a vacuum.
Yeah.
Probably wouldn't matter much. If you lived in a place that was 70 degrees year-round, you'd be fine. But in the real world, we have seasons. Specifically, we have winter.
Ah.
And the source material identifies the freeze-thaw cycle as the single most destructive force in the masonry world.
This is where the numbers get scary. I saw this stat in the notes, and I'm going to double check it. When water freezes, it expands by roughly 9%.
9%. That is everything. That's the difference between a house that stands for 100 years and one that crumbles in 20.
So imagine that expansion happening inside the microscopic structure of a brick.
The water is trapped in those pores we talked about. It freezes. It wants to grow by 9%.
But there's no room.
There's no room to grow. So it creates this immense internal pressure. It's not just pushing out, it's literally tearing the material apart from the inside.
One of the articles described it as a slow-motion jackhammer.
That's a perfect description. It's hydraulic pressure. And over time, that pressure exceeds the tensile strength of the masonry. And that leads to a phenomenon called spalling.
Spalling. We see this term a lot in the research. It sounds technical, but what does that actually look like?
Spalling is when the face of the brick literally pops off. You might walk out on your patio after a hard winter and see flakes of red clay, or chunks of brick lying on the ground.
Oh, I've seen that.
That's scalding. The internal ice pressure has blown the face of the brick off.
So if I see red chips on the ground, that isn't just shedding. My chimney is essentially exploding in slow motion.
Precisely. And here's why that is so dangerous. The face of the brick is usually the hardest, most fired part. Once that hard outer shell is gone, the soft, porous interior is exposed to the elements.
So the sponge is even more absorbent now?
Now the sponge is even more absorbent. The decay just accelerates exponentially. It's a blinking red light that structural damage is underway.
Okay, so naturally a homeowner sees this. Maybe they find a chunk of brick on the driveway and they panic.
Right.
They go to the hardware store, aisle 14, and they see a bucket of something called Super Seal 5000. They buy it, climb up a ladder, and slather it on. Problem solved, right?
You would think so. I mean, it seems logical. Hole in bucket, plug hole. But this is actually where we get into what the sources describe as the great sealant scam, or, at least the great misunderstanding of building science.
This was the part that absolutely blew my mind. The idea that trying to waterproof your chimney can actually destroy it faster, how is that even possible?
It depends entirely on the chemistry. Most of those over-the-counter products you find at the big box stores are silicone-based.
Okay.
And you should think of silicone like a plastic wrap. When you paint that onto a chimney, you are creating a film, a solid barrier.
Which keeps the rain out. That's the goal.
It keeps the rain out, yes. But here's the catch. Masonry needs to breathe. We generate a massive amount of moisture inside our homes. Think about it. Cooking pasta, taking hot showers, even just breathing.
Sure, all that water vapor.
And don't forget the combustion gases from the fireplace itself. That moisture travels outward through the walls.
Oh, I see where this is going. If I've wrapped my chimney in plastic wrap.
The moisture gets trapped. It travels through the brick from the inside. It hits that silicone barrier you painted on, and it can't escape.
It just condenses.
It condenses right behind the sealant. So you've just trapped a layer of water between the brick and the sealant.
And then winter comes.
Exactly. That trapped water freezes, expands that fatal 9%, and because the outer face is sealed tight with silicone, the pressure builds up until it blows the face of the brick off.
So it's exploding from the inside out.
From the inside out. You have essentially suffocated your chimney.
That is tragic. You're trying to save your house, you spend your weekend on a ladder, and you end up accelerating the destruction. So if silicone is the villain, what's the hero?
The professionals use what are called vapor-permeable membranes. The specific chemicals mentioned in the research are siloxanes or silanes.
Siloxanes, okay. How are they physically different from the plastic wrap?
They don't form a film on the surface. They are penetrants. They soak deep into the masonry and coat the pores themselves with a hydrophobic or water-repelling layer.
So the pores remain open.
Exactly. The pores are still there, but they are now lined with a material that liquid water can't grab onto. Brain just bounces off. And this is the crucial part. Water vapor molecules are incredibly small.
Smaller than a raindrop.
Much smaller than a liquid raindrop. They're small enough to pass right through those open pores.
So the moisture from my shower or my pasta water can still escape through the bricks, but the driving rain can't get in.
Precisely. The chimney can breathe. It stays dry on the inside, which stops that freeze-thaw cycle right in its tracks.
It sounds like the difference between wearing a plastic garbage bag and a high-end technical rain jacket.
That is the perfect analogy.
One makes you sweat and clammy, the other keeps you dry and comfortable.
You want your house wearing Gore-Tex, not a trash bag.
Now, to really understand how this works in the extreme, a lot of our source material comes from a specific case study in Portland, Maine. Specifically, zip code 04101. Why is this specific geography so important to the story?
Well, Portland, Maine, and the Pacific Northwest in general, they act as a sort of stress test laboratory for masonry. It's not just about heavy rain. In fact, heavy rain sometimes isn't the worst thing. It can wash a building clean.
Okay.
The problem in these areas is the misty threat. It's the persistent high humidity dampness from places like Casco Bay. In these climates, masonry never really gets a chance to dry out naturally during the winter.
It's just always damp.
A chimney that might last 50 years in a dry climate like Arizona might start failing in 15 years in Portland because of what they call a microclimate of decay. It's that constant saturation.
It never gets a break.
Right. And that constant dampness invites other guests. The sources talk a lot about moss and algae.
I see that on roofs all the time. It looks kind of rustic, almost charming.
It looks charming.
Like an English cottage.
Right. But structurally, it's destructive. Moss isn't just sitting there. It has root systems. It digs into the mortar, physically loosening it. Worse, think about what moss feels like.
It's a sponge.
It's a sponge. It holds moisture against the brick 24/7. Even when the rain stops, the moss is keeping the brick wet. It just accelerates the rot significantly.
There was also a note about the wind. Knowing which side of the house takes the beating.
Yes, specifically regarding nor'easters in that region. If you have a chimney on the north side of your house in Maine, it's taking the brunt of wind-driven rain.
Oh, right.
That pressure forces water deeper into the bricks than gravity alone would. It's a relentless physical assault.
So let's say I'm listening to this and I'm starting to get nervous about my own chimney. I'm not a structural engineer. How do I read my chimney? What are the diagnostic signs I should be looking for?
There is one major visual clue that the sources call a blinking red light, and that is efflorescence.
Efflorescence. That's the white powdery stuff you sometimes see on brick.
Yes, people often brush it off as just salt or a stain, and chemically, it is salt. But you have to ask yourself, how did it get there?
Okay, lay it out for us. How did it get there?
It got there because water moved through the masonry. That water dissolved the natural minerals, the salts, inside the brick or mortar and carried them to the surface. When the water evaporated, it left the salt behind.
So if you see white powder, it is proof positive that water is traveling through your chimney.
It's like the chimney is sweating salt. It means the waterproofing, if there ever was any, has failed. The sponge is full.
What else should we look for besides the white powder?
Look closely at the mortar joints. Are they cracked? Do they look melted?
Melted.
Yeah, that's the term they use. If the mortar looks like it's flowing or washing away, or if it's receding back from the brick face, that's bad. It means the binder in the mortar is dissolving. Also, trust your nose.
Okay.
If you walk into your living room and smell a musky, damp odor coming from your fireplace, that's not normal.
That old basement smell.
Right. That is the smell of stagnant water and potentially mold inside the chimney structure. It means the water isn't just in the bricks, it's getting into the home.
There was one terrifying phrase in the notes, hollow shells. Can you explain that? That sounds like something out of a horror movie.
That's the invisible threat. The sources mentioned finding chimneys that looked okay on the outside, maybe just a little weathering, nothing too dramatic. But because of that internal water movement we discussed, the internal mortar had completely washed away. It had turned to sand and just fallen to the bottom of the flue.
So the bricks are just sitting on top of each other.
Held together by gravity and habit. The structure was effectively a hollow shell. A strong wind could just topple it.
That is a nightmare scenario.
It happens, and that's why you can't always judge the health of the structure just by looking at the face of the brick. You need to know what's happening inside.
So we've covered the bricks. But the deep dive here suggests that holistic protection involves more than just the masonry. We need to talk about the other components, the crown, the cap, and the liner.
Right. Let's start with the crown. The crown is the concrete slab at the very top of the chimney. It's the roof of the chimney, essentially.
Okay.
The problem is most of them are built poorly. They're often just standard mortar sloped to the edge. They crack easily. And once they crack,
water just pours right down into the walls of the chimney.
Exactly. It's like leaving a skylight open. A professional repair doesn't just patch that crack with cement. They apply a flexible elastomeric membrane.
Elastomeric. That implies it stretches.
Correct. It's a rubberized coating that can stretch and move with the temperature changes. Masonry expands and contracts. A rigid patch will just crack again in a year. An elastomeric membrane bridges those cracks so the water sheds off properly year after year.
And then there's the cap.
The stainless steel chimney cap. Think of it as the umbrella. Without a cap, you essentially have a giant hole in your roof. Keeps out rain, snow.
Birds, squirrels.
Oh, yeah. It's a mess. And a nest can block the airflow, which is dangerous. The cap is your first line of defense. It's non-negotiable.
Now let's talk about the liner. The sources were very specific about the shift from old clay tiles to stainless steel liners. This seems like a big job. Why is this upgrade so important?
This is where we shift from structural preservation to life safety. Many older homes, especially in that Portland area we discussed, were built with clay tile liners, or sometimes no liner at all.
Oh, wow.
And clay is porous. It cracks over time, especially with that salt-heavy humidity. And if the liner cracks...
It's not just water getting in.
No. This is critical. If the liner is cracked, carbon monoxide can leak into the home living space instead of going out the roof. Or heat from a chimney fire can transfer through those cracks to the wooden framing of the house.
Yikes. So a crack liner is a fire hazard.
A major one. Also, modern heating appliances, high-efficiency furnaces, they output exhaust. that is cooler and more acidic than old wood fires. Old clay liners can't handle that. They crumble. A stainless steel liner is a sealed system. It contains everything.
Okay, so we've got the science, and we know what materials to use: silanes, stainless steel, elastomeric membranes. But let's talk about the actual application, because the sources emphasize that this isn't a spray and pray situation.
Not at all. Precision matters. You cannot just spray waterproofing on a dirty or broken chimney. Step one is always cleaning. You have to remove the soot, the dirt, the moss, and any old failed sealers.
And then the repairs, right? You can't waterproof a crack.
Correct. It's called tuck pointing. You have to cut out the bad mortar, grind it out, and replace it. Only then, and this is critical, you have to wait for the dry window.
The dry window. This is the part that makes scheduling this work tricky, I bet.
It is the bane of contractors in wet climates like Maine. The sources state you need 24 to 48 hours of dry weather. The masonry has to be bone dry.
Why is that?
If you apply a waterproofer to a wet brick, even a breathable one, you aren't getting that deep penetration we talked about. You're just sealing the water in.
So you need a couple of sunny days in Maine. Good luck with that.
It's a challenge. That's why late spring, summer, and early fall are the prime times for this work. And when they do apply it, they use a saturation technique. They don't just mist it on. They soak the masonry until it physically cannot hold any more liquid.
You drown it.
You drown it. This ensures that chemical bond goes deep into the brick, creating a barrier that lasts for a decade or more.
Let's talk about the financial reality of this. We mentioned that $30,000 rebuild cost earlier, but what's the ROI on waterproofing? Is it worth it?
It's framed as the difference between routine maintenance and a financial catastrophe. Waterproofing costs a small fraction of a rebuild, but there's another angle the sources mention: real estate value.
Oh, right. The inspection.
If you are selling your home, the home inspector will look at the chimney. They always do. A crumbling chimney is a deal killer. It's a massive red flag that screams deferred maintenance.
It makes buyers wonder what else is broken.
Exactly. It erodes trust. But if you can show a receipt for a professional waterproofing with a transferable warranty, that turns a liability into a huge selling point. It tells the buyer, this house was loved. This house is dry.
It's peace of mind.
It is. It preserves the asset.
So we've gone from the vertical sponge to the science of siloxanes. It's amazing how much complexity is hidden in a simple stack of bricks.
It really is a battle of materials versus elements. The brick wants to absorb. The water wants to freeze. The homeowner just wants to stay warm.
And safe. I think that's the underlying message here. The sources keep coming back to safety.
Absolutely. We talk about money and maintenance. But a compromised chimney is a physical hazard. Bricks falling off the roof are dangerous. Carbon monoxide is dangerous. Fire is dangerous. This isn't just about curb appeal.
Well, that definitely puts checking the chimney higher on my to-do list. I think I'm going to go out and look for white powder as soon as we finish this.
As everyone should.
I want to leave our listeners with a final thought today. We talked about the patch and pray method, grabbing a caulking gun and just filling a crack, hoping for the best.
The most common mistake.
Think about the physics we discussed. Thermal expansion. That brick is moving, expanding, and contracting with the heat and cold every single day. That caulk you put in there. The physics of your house has likely already ripped it apart. So look at your home today and ask yourself, is it breathing? Or is it suffocating under a layer of plastic, waiting for that next freeze to blow?
That is the question.
Thanks for diving deep with us. Stay dry out there.